Jai Hind, myself Dr. Alok Vardhan. Currently, I am working as an assistant professor in the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. In this lecture, I will discuss one of the important topic of the subject fluid mechanics and fluid machines, and the topic is hydraulic pumps. So, in this lecture, I will discuss what is hydraulic pumps, then their classifications, then two important pumps like centrifugal pump and reciprocating pump, their construction and working, then comparison between centrifugal pump and reciprocating pump, then what is cavitation, what is priming. After then I will discuss what is effect of acceleration on the performance of reciprocating pump. So let's start. What is hydraulic pump? So basically, hydraulic pump is a hydraulic machines which convert the mechanical energy into hydraulic energy. Means hydraulic pump convert mechanical energy into hydraulic energy. Then what is classification of hydraulic pumps? So basically, hydraulic pumps are classified based on three parameters. These parameters are based on operating principle. So based on operating principle, hydraulic pumps are classified as positive displacement pump and non-positive displacement pump. What is positive displacement pump? यानी कि if pump delivers fixed quantity of volume at every revolution, then this type of pump is called positive displacement pump, like reciprocating pump, gear pumps and piston pump. And if it is not necessary to deliver fixed amount in every revolution, then this type of pump is called non-positive displacement pump, like centrifugal pump. Then the second classification is based on fluid displacement. According to fluid displacement, the pumps are classified as fixed displacement pump and variable displacement pump. Means if pump delivers fixed quantity in every revolution, then this type of pump is called fixed displacement pump. But if there are provision to vary their volume in every revolution, then this type of pump is called variable displacement pump. Then the third classification is based on direction of flow. Based on direction of flow, the pump is classified as unidirectional pump and bidirectional pump. Unidirectional means if pump rotate only in anti-clockwise or clockwise, then this type of pump comes under the category of unidirectional pump. And if same pump can rotate in clockwise as well as in anti-clockwise, both direction, then this type of pumps comes under the category of bidirectional pump. So this is the classification of hydraulic pumps. Then now I will discuss construction and working of centrifugal pump. So what is construction? So basically, a centrifugal pump primarily consists of following components. The first one is casing. This is casing. It has volute shaped enclosure that houses the impeller and directs fluid to the delivery pipe. Then second one is impeller. This one is impeller. What is impeller? It is rotating component with blades that imparts kinetic energy to the fluid. Then third component is suction pipe. This suction pipe. It connects the fluid source to the impeller eye. This is impeller eye and this is fluid source, yes, sump. It connects the fluid source to the impeller eye. Then delivery pipe, this one, delivery pipe, carries fluid from the pump to the outlet. Then footwall. This is footwall with strainer, foot valve with strainer. What is foot valve? ये one way valve at the suction pipe end that allows fluid in but prevents backflow, maintaining prime. Then what is the function of strainer? A mesh attached to the foot valve to block debris and protect the pump from clogging. So these are the main components and their functions of centrifugal pump. Then what is the working behind centrifugal? So when the impeller rotates, it imparts kinetic energy to the fluid, causing it to move outward due to centrifugal force. After then, this motion reduces the pressure at the impeller eye, allowing fluid to flow into the pump from the suction pipe. The fluid then flows radially outward through the impeller vanes, gaining velocity and pressure. In the volute casing, the high velocity fluid is converted into pressure energy and the fluid is discharged through the delivery pipe, and this process ensures a continuous flow of fluid. So this is the working behind the centrifugal pump. Then the second pump is reciprocating pump. This is the schematic representation of reciprocating pump, single acting reciprocating pump. If I am talking about its construction, then a reciprocating pump mainly consists of the following components. First one is cylinder. This is cylinder. A strong hollow tube in which the piston moves back and forth. A strong hollow tubes in which piston moves back and forth. Then second one is piston. This is called piston. Moves inside the cylinder to create suction and delivery. Then third one is crank and connecting rod. This is connecting rod and this one is crank. It converts rotary motion of the piston into the reciprocating motion of the crankshaft. Then next one is suction valve. This is suction valve. This one is suction valve. Allows fluid to enter the cylinder. Allow fluid to enter the cylinder during suction stroke. It is a one-way valve. Then delivery valve. This one allows fluid to exit the cylinder. Allow fluid to exit the cylinder during delivery stroke. Also a one-way valve. Then suction pipe. This is the suction pipe. Carries fluid from the source to the pump, and this is delivery pipe. It carries fluid from the pump to the delivery point. This is the main component of a reciprocating pump. Then what is the working behind a reciprocating pump? So the full working of reciprocating pump is divided into two strokes. First one is suction stroke and second one is discharge stroke or delivery stroke. In suction stroke, the crank rotates and pulls the piston away from the cylinder head towards the outer dead center. Due to this, increases the volume of the cylinder chamber and reduces the pressure inside it. Because of the pressure drop, the suction valve opens due to higher atmospheric some pressure outside, and fluid enters the cylinder from the sump or reservoir through the suction pipe and valve, and the delivery valve remains closed during this stroke. Then in delivery stroke, the crank continues to rotate and now pushes the piston towards the cylinder head, means towards the inner dead center. Due to this, decreases the volume inside the cylinder, thereby increasing the pressure. When the pressure inside the cylinder exceeds the delivery pipe pressure, the delivery valve opens and the fluid is forced into the delivery pipe and sent to the desired location. Meanwhile, the suction valve closes to prevent the backflow into the suction pipe. Now, I will discuss the difference between centrifugal pump and reciprocating pump. According to working principle, centrifugal pump works on centrifugal force, whereas reciprocating pump works on positive displacement. According to flow nature of flow, in centrifugal pump there is continuous and smooth flow, whereas in reciprocating pump there is intermittent and pulsating flow. According to efficiency, centrifugal pump has high efficiency at high flow rates, whereas in reciprocating pump it has high efficiency at low flow rates. According to design, it is simple design with fewer moving parts, whereas reciprocating pump have complex design with more moving parts. According to priming requirement, centrifugal pump requires priming before operation, whereas reciprocating pump does not require priming. According to pressure development, it develops lower pressure. Centrifugal pump develops lower pressure, whereas reciprocating pump develops higher pressure. According to handling of fluids, centrifugal pump suitable for low viscosity fluids and large volumes, whereas reciprocating pump is suitable for high viscosity fluids and small volumes. According to speed of operation, centrifugal pump operates at high speed, whereas reciprocating pump operates at low speeds. According to maintenance, centrifugal pump have low maintenance due to fewer moving parts, whereas reciprocating pump have higher maintenance due to wear and tear of moving parts. And lastly, according to applications, centrifugal pump is used in irrigation, water supply and large scale industries, whereas reciprocating pump is used in hydraulic systems and high pressure application. So, this is the difference between centrifugal pump and reciprocating. Then what is manometric efficiency, mechanical efficiency and overall efficiency of centrifugal pump? What is manometric efficiency? So basically, manometric efficiency is the ratio of manometric head to the theoretical head. It measures how effectively the pump converts the energy imparted by the impeller into the pressure energy. So mathematically, we can say that manometric efficiency eta m is the ratio of manometric head to the theoretical head. Then second one is mechanical efficiency. So basically, mechanical efficiency is the ratio of power delivered to the impeller to the power input to the shaft. It accounts for mechanical losses due to friction and other resistance in the pump components. So mathematically, mechanical efficiency eta m is the ratio of water power to the shaft power. Overall efficiency. So basically, overall efficiency is the product of manometric efficiency and mechanical efficiency. So it represents the ratio of useful work to the total power supplied to the pump. So these are the efficiencies regarding the centrifugal pump. Then what is cavitation? Basically, cavitation occurs when the pressure in a liquid drop below its vapor pressure, causing the formation of vapor bubbles, and these bubbles collapse violently when they moving into the higher pressure zone, causing noise, vibration, loss of efficiency and potential damage to the pump's component. So cavitation for any pump is not desirable. Then what is priming of centrifugal pump? So basically, priming is essential in a centrifugal pump because it cannot handle air or gases efficiently. So the process involves filling the pump casing and suction pipe with liquid to remove air or vapor, ensuring proper suction and preventing issues like cavitation or pump failure is called priming of centrifugal pump. Then what is slip, percentage of slip and negative slip with respect to reciprocating pump? So basically slip is the difference between the theoretical discharge and actual discharge of the pump, whereas negative slip occurs when the actual discharge is greater than the theoretical discharge, and this usually happens when the pump operates at very high speed. Yeah, the inertia of the water in the delivery pipe enhances the discharge. Then what is percentage of slip? The percentage of slip is theoretical slip minus actual slip divided by theoretical slip into 100 is called percentage slip. Then what is the effect of acceleration on suction and delivery pipe of indicator diagram of reciprocating pump? So first of all, I will discuss what is ideal indicator diagram. After then, I will discuss the effect of acceleration. So basically, the ideal indicator diagram represents the variation of pressure inside the cylinder of a reciprocating pump during one complete cycle of operation, assuming no losses like friction, acceleration effect, etc. It is a graphical plot of pressure versus the piston displacement. So this diagram represents the ideal indicator diagram. It is the graph between stroke length versus pressure head. Now, what is the effect of acceleration on this ideal indicator diagram? Basically, in reality, the fluid in the suction and delivery pipes has mass which requires acceleration and deceleration during the pump cycle. This causes derivation from the ideal indicator diagram. So, during suction stroke, at the start of the suction, the fluid in the suction pipe accelerate. This create a temporary drop. This create a drop in pressure, resulting in a curve below the ideal suction line. So this will start from A dash here. Then towards the end of the stroke, deceleration may cause a slight pressure rise above the ideal line. So this will start from this B dash point. So this is the effect of acceleration on the suction side of this diagram. Then during delivery stroke, at the beginning of the delivery, the fluid in the delivery pipe needs to be accelerated. This cause a temporary pressure rise, creating a curve above the ideal delivery line, and due to this, it will start from point C dash, and during deceleration towards the end of the stroke may result in a slight drop in pressure below the ideal pressure line, and in this one. So this is the effect of acceleration on ideal indicator diagram during delivery stroke. So in ideal case, the ideal indicator diagram is ABCD, but considering the effect of acceleration, it will becomes A dash, B dash, C dash and D dash. So this is the effect of acceleration in suction and delivery pipes on the indicator diagram. So this is all about for this lecture.